Hello friends, welcome back to the class. I think it is very long time having the class. So in this video we are going to discuss about intermolecular cyclo addition reactions. So what are the intermolecular cyclo addition reactions? How many types of reactions are there? And PhotoCyclo addition of alkenes we are going to discuss in this class. So friends, intermolecular cyclo addition reactions. So the word inter represents two molecules are involving. That means in between the molecule, if reaction takes place, that is called intermolecular. So therefore more than one molecule is involving in reaction. So photochemically, intermolecular reactions of olefins are four types. What are those four types? PhotoDimerization, PhotoCyclo Addition, addition of olefin to alpha beta unsaturated carbonyl compound, and photo addition reaction. So friends, let's start the first reaction, PhotoDimerization. So generally alkenes undergoes dimerization reaction. Dimer means two same type of molecule added to each other give a big molecule or huge molecule, that's called dimer. So here alkenes generally undergoes dimerizations. These dimerizations are two types. One is a concerted 2+2 cyclo addition, that is called pericyclic reaction. We already discussed about this reaction in pericyclic chapter. Example is ethylene undergoes addition reaction. This addition reaction is 2+2 cyclo addition, gives a product cyclobutane. Another one is non-concerted reaction. So what is non-concerted cyclo addition reaction? This non-concerted cyclo addition, nothing but two-step reaction or multi-step reaction. It is involved by formation of diradical intermediate. Here these are sometimes non-stereospecific reactions, sometimes partially stereospecific reactions. So friends, this is about photodimerization. For example, let's take cis-2-butene. It is on photochemical irradiation. We get two types of products, and here you observe this, the stereochemistry of groups on the reactant are going to retain in the product, but that is, you can observe the two CH3 groups are cis to each other. In product also those two CH3s are cis. Here another molecule of 2-butene, yes, the two CH3s are cis. Here also you can observe that the same thing. So how this product is forming? When the two butenes are taken in this orientation, we get the first product. When you take molecules like this, we get this product, second product. Similarly, trans-2-butene give two products with retaining the stereochemistry. So the two CH3s are trans to each other, the two CH3s are trans to each other, because we are taking this orientation. Here this product has obtained by taking the trans-2-butene in this orientation, opposite direction. So next one, norbornene. Norbornene undergoes dimerization. We get two products, exotrans-endo and also exotrans-exo product. What is this? You can observe here, this is directly undergoing cyclo addition. So when it is undergoing cyclo addition, here the two hydrogens are coming to top side. According to this ring, the two hydrogens are endo, that's why exo, outside exo, and you can observe the hydrogens are trans to each other. According to this ring system, these are endo, That's why it is exotrans endo. Another one is exotrans exo. So next friends, at this reaction you can simply observe. So here what is happening, this pi bond undergoes homolytic cleavage, this is also undergoing homolytic cleavage. Radicals are going to form this position. Here radicals are formed, and the formed radicals, so these radicals are going to make the bond and we get this bond, and the remaining radicals are formed here. These radicals are, we are going to call diradical intermediate. Now these diradicals make the bond, we get a product, this product. Okay, next PhotoCyclo addition reaction. So PhotoCyclo addition is nothing but the same open chain alkenes undergoes dimerization in stereospecific mode. What kind of reaction it is? 2pi cyclo addition. You observe this, it is supra mode of addition only takes place, but the product is going to obtain in very less yield. So here two different molecules involved in this reaction, the different molecule you can observe. So this is A double bond A molecule, B double bond B molecule, that this pi bond shifted here, we get a sigma bond here. This pi bond is going to shift here, we get another sigma bond, finally we get a cyclic adductor. So PhotoCyclo additions are generally singlet excited state concerted reactions, singlet excited state concerted reactions, and in the product the stereochemistry of ground state partner and also excited state partner retain in the product, because what kind of mode of addition is taking place? Supra. When pi partner is involving in supra mode of addition, the stereochemistry of that partner always retain in the product. So let's see some examples. Okay, so you can observe. So we get the same type of dimerization reaction, and here a cyclohexene having pH group, phenyl cyclohexene, on dimerization it gives a diradical intermediate. So but two types of products are going to form. So this is a cis, so trans or cis product. This is a cis fusion, this is a cis fusion. So this is called cis transide cis. Okay, the next one cyclohexene also give the same thing, right? Here non-stereospecific reactions, because so when you take a single molecule we are going to take more number of stereochemical product, so that's why it is a non-stereospecific reaction. And here, so let's see an example. So this is the example. So in this example you can observe the benzene undergoing cycloaddition with this olefin. So how it is undergoing, friends? You see, so the pi bond of benzene is shifting here, this pi bond shifting here. Okay, we get cyclobutane derivative. When you heat the compound, this is a strained ring. This part is strained ring. This is going to involve in, so what kind of reaction? Yes, electrocyclization reaction like this. So this electrocyclization reaction going to give this product. So this is on hydrolysis. What is happening? So this is eliminated. Now we get a double bond at this position. So friends, the same kind of reaction we can observe with methyl acrylate. Okay, another reaction is benzene react with acetylene. Benzene react with acetylene, we get this intermediate. This intermediate undergoes, yes, right, electrocyclization reaction like this. So this electrocyclization reaction going to give cyclooctatetrene. So friends, this is about PhotoCyclo addition reactions. So next let's start addition of olefins to alpha beta unsaturated carbonyl compounds. So friends, the cyclo addition of alpha beta unsaturated carbonyl compound and with a different olefin molecule. So means the one reactant is alpha beta unsaturated molecule, another reactant is alkene. Sometimes we can also take alkyne. So this reaction takes place in presence of light. So that is it is a PhotoCyclo addition reaction. Here alpha beta unsaturated compound undergoes intramolecular cyclo addition to give cyclobutane derivative. So addition takes place through triplet state pi to pi star excited condition. So let's see an example. Cyclopentanone react with olefin. So this is alpha beta unsaturated carbonyl molecule. You can observe here, this is alpha position of carbonyl group, this is beta position of carbonyl group. So now what is happening, on irradiation with light we get two products. Cyclo addition like this. So this pi bond shifted here, this pi bond shifted here, we get cyclobutane derivative here. Another product also going to form, so like this. But my question is, in between these two products, what is the major product? Here the first one is major, second one is minor. These two are regioselective products. So let's see why the first one is major, why the second one is minor. So this can be explained by using mechanism. So we are starting with alpha beta unsaturated carbonyl compound react with olefin. When you irradiate with light, so this molecule is undergoing this molecule is undergoing excited state, forming singlet excited state. After that ISC, intersystem crossing, this is going to form in complex, or it is called one type of transition state where these two molecules are come closer to each other, having an interaction between the two pi bonds. So you can observe the two pi bonds are going to have an interaction. So this complex is called exciplex. What we are calling exciplex. What is the exciplex? The transition state formed in the reaction is called exciplex. Now you can see that here the pi bonds, what they are in interaction, it is undergoes homolytic cleavage, it is also undergoes homolytic cleavage. We get a radical at these positions. Now these two radicals make the bond. So here we have a radical, here also we have a radical. Okay, so the two radicals are obtained after the breakage. So the bond has formed, the two radicals are formed. So this is one way to form the radical. So another way is, so you can take this olefin in opposite direction like this. So when you take this olefin like this, now here we going to make a bond here, so we get this compound. Okay, so now you can observe the two radicals are present in the molecule. This is called diradical intermediate. Okay, so now my question is, in between these two intermediates, so which is a stable intermediate? So here this is a secondary radical, it is a secondary radical, that's why. So both are equal energetic, but so this radical is a tertiary radical where it is a primary radical. So we know that the tertiary radical is always stable. Therefore this intermediate is stable, where this intermediate is unstable. Now these two radicals make the bond, we get a product, yes, this one, and these two radicals make the bond, we get the product like this. And this product is obtaining from stable radical. So that's why right here this product is obtaining from stable radical, that's why it is a major. This product is obtaining from unstable radical, that's why it is a minor. So friends, this is about the mechanism of the reaction. So let's see some characteristics of this reaction. So that means how the addition of alpha beta unsaturated carbonyl compound with olefin is taking place. Now characteristics. So here the reaction mixture is irradiated at absorption wavelength of carbonyl compound. So at which position we are irradiating? We are irradiating at absorption position of carbonyl compound. So here the excited states are N2 pi star triplet state, which is excited state because carbonyl compound is present, that's why it is undergoes N2 pi star excited state, and these are triplet state reactions. And what is the intermediate in this reaction? 1,4 diradical or biradical intermediate. Here if olefin is unsymmetrical, then it is going to produce stable diradical intermediate. And here before formation of diradical intermediate, it is going to form a transition state that is called exciplex. What is that? Exciplex with a ground state olefin. And here if there is a stereochemistry for ground state olefin, the stereochemistry of olefin is lost. That means stereochemistry of reactant is not going to present in the product. And the olefin, yes, nucleophilic carbon going to develop CC bond with the alpha position of carbonyl carbon. So olefin carbon going to make a CC bond with the alpha position of carbonyl compound. So in product, cis fusion is predominant for 5-membered rings. So which cis fusion is there? Trans fusion is there. When alpha beta unsaturated carbonyl compound is 5-membered ring, then cis product is major. If that alpha beta unsaturated carbonyl compound is a 6-membered ring, then trans fusion is major. When alpha beta unsaturated carbonyl compound is 5-membered ring, cis product is major. Alpha beta unsaturated carbonyl compound is 6-membered ring, trans fusion is major. Let's see an example. Yes, let's see the example here. So here you can see that this is the alpha beta unsaturated carbonyl compound, 6-membered ring, react with dinitrile olefin. So first it is forming a complex, a transition state that is called exciplex. Now it is going to make the sigma bond with alpha carbon and olefinic carbon, we get a sigma bond. This olefin can be oriented in two orientations. So one orientation give radical at 2 cyanide carbon, carbon of 2 cyanide groups. Another one is this intermediate. So two intermediates are formed. Here you can observe that the cyanide group is electron withdrawing group. Therefore, when radical attached to electron withdrawing group attached to carbons, that is unstable radical. So here this carbon radical is not attached to electron withdrawing group, that's why it is stable radical. Where it is unstable, it is stable. So now these two radicals make a bond, we get the minor product. So these two radicals make the bond, we get the major product. You can observe, friends. So in before case, here this product is major, but here it is this is minor. Why? Here the two cyanide groups are present. These two cyanides are electron withdrawing groups. So electron withdrawing groups going to make the radical is unstable. So now this carbon is having electron, so without having any electron withdrawing groups on that carbon, that's why it is stable radical comparatively the first one. That's why stable radical give the major product. So let's see other examples. So I already told you, when the olefin is when alpha beta unsaturated carbonyl compound is 5-membered ring, yes, cis is major, the fusion is cis fusion is major, where trans fusion is minor. So cis is major, trans is minor. When the olefin is a 6-membered ring, yes, you can observe cis is minor, where trans is major. So friends, this is about the cyclo addition reactions we have in our syllabus. Thank you. We will meet in the next class.